Morning to all the participants. I am very glad to invite our today's resource person, Dr. Shankar. Dr. Shankar K is an assistant professor in the Department of Electronics and Instrumentation Engineering, NIT Silchar. He completed his undergraduate engineering degree in Instrumentation and Control Engineering discipline at Arulmigu Kadasalingam College of Engineering, Tamilnadu in the year 1998 and MTech in Biomedical Engineering at Indian Institute of Technology, Madras, Chennai in the year 2006. He was awarded a PhD degree in the broad area of biomedical engineering from Anna University, Chennai in the year 2017. He has been teaching the instrumentation and allied engineering courses for 2 decades. Before joining NIT Silchar, he was serving in various positions from lecturer to associate professor in the Electronics and Instrumentation Engineering Department of National Engineering College, Kovilpatti, Tamil Nadu. Dr. Shankar is more passionate in paint research and tries to explore the objectivity in paint. However, his research interests also include the broad areas of biomedical instrumentation, human factors engineering, automation, environmental instrumentation, technology for societal issue and entrepreneurship development. He has published and presented research papers in various national and international journals, books, as well as conferences. He has guided many PG engineering students and is guiding a PhD scholar too. Now, I invite Dr. Shankar sir to present over the topic of sensors for healthcare industry. Please, sir. Shankar sir.
Yeah, thank you so much for a nice introduction from your side. It's my pleasure to be here with you all, my dear fellow teachers and my dear participants. It's my honor to be also here with my friends, Dr. Karpasamy and my other fellow speakers. So at the outset, I would like to thank, formal thank to ATAL Academy for having sponsored this FDP to P.S.R Engineering College and having accepted our talks in this FDP. And I thank P.S.R Engineering College management, especially the managing trustee and correspondent through R. Solisamy sir and the managing trustee and director Mrs. Vigneswari Arun Kumar ma'am, principal Dr. Vishnuram sir, dean Dr. Marichami sir. He was my senior when I was there in National Engineering College. Very nice person. And Professor and Dean Research Dr. Shagulamit sir and Madam Valarmadi Madam, Dr. Valarmadi Madam, Professor at VCB, and my friend Dr. Karpasamy sir, Professor of PCB, and other organizing coordinators, Ranjit Kumar sir, Vinod sir, and Santosh sir. I thank you all for inviting me to this FDP as a speaker. And of course, I have to thank my dear participants also. I cannot say the participants, we all are friends and we can discuss the things, whatever we need to do and we'll discuss. So I thank you all for being here and we'll discuss the topic. Okay, so today's topic is actually sensors for healthcare industries. Let me share my slides. And my dear friends, actually, I have very minimum number of slides only. So don't worry. I hope I will not be boring you guys. If you feel it's bored, and you can stop at any place and you can start discussing the points, whatever you want to say, right? So let's all listen other speakers in the participants list also. Okay, and I'm also saying that I'm not expert. I cannot say I am expert in this sensor in healthcare industry side, and I'm not. Some of you might have been gooder, might have been uh, good in talking sensor for healthcare industries, and you may be the expert in sensor and healthcare industries. So you can also take participate in this discussion, and if I say anything irrelevant, you can correct me at any point of time. Okay, so with this declaration, I am starting my session. And again, one more point I want to say that these sessions, this session, in fact, I am not going to present any research outcomes, right? Means any data of research outcome and or inferences of any data of research, right? And I'll be discussing about what is sensor, especially pinpoint to the healthcare industry and what is healthcare industry, and a few point about the Indian healthcare industry scenario presently, and few sensors in healthcare industry. I'll be concentrating mostly on the vitals, right? Vital parameters only. I'm not going very broad. So it will cover some 4 to 5 slides, and I'll be talking about my research area, the pain measurement, and what I have done in my research and what I have developed in my laboratory for conducting experiments.
Sir, maximize your screen, sir.
Okay. Yeah.
Thank you, sir.
Yeah. Good. Is my do you need my video available? Should I unmute my video?
Sir, tell me, sir. Excuse me, sir. Sangur, sir.
Okay. So, and later slides, I will be talking about my research area and what I have done in my laboratory, what I have developed research purpose. I have done a few pain induced mechanical and thermal based, and I got level of means I got tested and I got validated those by using those devices. But human science, those are promising to my level, and we have published those results also. And still, I am continuing my research. Okay, so this is how my presentation will be going on. Maybe I will be having some 15 slides, including the introduction and thank you. So 30 slides will be 13 only. Don't worry about 30 slides. So slides will finish my talk probably within an hour, right? So anyhow, if in of technology, Silchar, and first, we need to discuss, as our topic is sensors for healthcare industry. So I am dividing this topic into two major parts. One is sensor and healthcare industry. So, so we need to listen, right? And we need to know this healthcare industry. Healthcare industries, okay. So the first right? In the history, how they, the sensors, how they were playing the role in diagnosing the diseases, right? So always it's very much necessary to discuss the history behind it. Okay, and is my voice not audible?
Now audible, sir. No problem.
Sir?
Now audible, sir.
Is it okay now? It's okay
Is
now?
it, sir? Yes, sir. Yes, sir. No problem. Please proceed, sir.
Maybe due to some internet interruption, connection interruption, it will be all right soon, okay? Please don't interrupt. No, I cannot do anything on it. Okay. So it's always very much important to talk about the history behind every technology, right? Even though we are engineers, we need to know the history behind it, and it will be very much useful for us to teach the students about technologies. Okay, so as such, we need to know the history behind sensor and history behind sensors also. So sensor is a word which has come from the word sense, right? So we can say what is sensor, like anything which senses anything is called sensor, right? In general we will talk. Anything which senses anything is called sensor. Okay, and of course it will sense the changes in anything, right? Here you can fill anything with this word anything, with this. Okay, you can say parameters or variable or physiology variable or anything, right? So some device which senses the parameters or anything, maybe you can fill, right, is called the sensor, right? And the device which senses the changes in anything, the changes in your parameter, your physiological variable or physical variable or industrial parameters, whatever it may be, your atmospheric parameters, anything it may be, right, is called the sensor. Okay, so what is behind the sensor is nothing but sense, right? It has to sense something, right? And leaving apart this engineering, technology, and science, everything, we have other senses with us also, right? Human being has its own senses, right? We have 5 senses with us, right? And those 5 senses operate the sensors in us, okay? And human beings have the sensors with us, and human beings have senses with us, right? So these sensors are the fundamental and basic for the sensors which we have now, right? So our sensor, the sensor technology and the sensor domain which operates on the basic of these 5 senses, I can say, right? So what are all those 5 senses and what are all those sensors? And we are seeing, this is one sense, and we are hearing, this is the sense, and we are smelling, it's a sense, right? And we are tasting the food, right? And it's a sense, and we are feeling by touching others, right? Touching anything, and it's also a sense, right? So especially in the case of healthcare, these 5 senses play a predominant role in diagnosing the diseases. It's very important. So I can say who is the best doctor? The doctor who has the sensing ability of these all senses could be considered as the best doctor. Okay, so if he senses the patient with all these 5 senses, then I hope there will not be requirement of any other sensors and transducers or devices or medical instruments, right? We can say examples from our own culture, means Tamil culture. Probably the participants from other parts of country might have also joined here, and you have also your own culture, your own traditional medicinal system. In our old traditional medicinal systems, we didn't have any such instruments, right? Our Vaidya or our that Siddhar, who it may be, our doctor, ancient doctors, they have just checked our pulse, radial artery pulse. Now we are saying, but in ancient days, what we have talked about, that nadi, right? Vata nadi, pitta nadi, and kapha nadi. They have said only, right? And they diagnose the patient, diagnose the person who is affected with any other illness with their sensors only. They smelled them, right? And they smelled their excretions, right? They smell their urine, they smell their feces, stools, right? And they smell their sweats, right? And they sometimes there were doctors, surprisingly they tasted the feces also and urine also. You know, in a case I'll be showing in the slide there, a doctor in a Western country, he tasted the urine of a patient to diagnose the diabetics. It's amazing. It's a miraculous. How can we accept and can we do this now? We cannot do it, but they did it and they diagnosed the diseases, right, with their sensors. So these sensors actually give a good input to develop your modern sensors, modern devices. Okay, so these are very important. Okay, and the history of diagnosis has been the history of doctors' use of the five senses. This is very important, my dear friends. Everywhere in the technological development or the advancements, the history is there. We need to check the history and how it has been evolved and where from it has come. It's very important. So the history of diagnosis has been the history of doctors' use of the five senses. So if suppose they are not identified these five senses of human being and they had not used their sensors, right? Now no sensor technology, of course, right? So this is very important. So what are the sensors we have? We have eye with us, and we have ear, and we have nose, and we have tongue, and we have touch means finger, using which we are feeling the touch, right, by the finger, right? So these are the sensors we have, very rugged, very sophisticated, much accurate sensors we have. And if something happened wrong with these sensors, and of course we cannot sense anything and we cannot diagnose the thing, right? This is what happened with our real-time sensors also, our main-made sensors also. If something happened there, malfunction happens there, and then your parameter results will be changed. Your results will not be accurate and your process will not be good, right? In the case of industry. In the case of your human physiology, if your parameter is something different, suppose if your sensor shows, if sensor reads and shows, your display shows your blood pressure like 150/55, then you will be getting scared, right? And you cannot do anything beyond that. So you need to know what is wrong with the sensor or what is wrong with you, either of the cases, right? So it happens in our sensors also, right? So our eye basically operates as an optical sensor, whatever we are having now, and it has long history behind it, right? And from here only we have developed many more optical sensors, many more medical optical devices, many more medical imaging devices here, right? And we have sound sensor or audio sensor, whatever it may be called, right? And from this sensor only, from understanding of the working of our ear, right, in the outer ear, middle ear, and inner ear, the drum inside, and how the sound wave goes inside, and how the brain process the sound which surrounds us and everything, right? So this is the thing which made us to develop many audio systems, right? Audio sensors, your mic, your speaker, and everything, your hearing aids, right? Your audio meter and your otoscope and everything started from here only. And you have nose, and our nose acts as a smell sensor, right? Nowadays, e-nose is very popular, and electronic nose is very popular, and doctors use VOC, volatile organic compounds from our human body, to diagnose a disease. We cannot believe that doctors nowadays started diagnosing the malignancy by smelling their breath out, exhale gas, right? And any other volatile organic compounds also, VOC, we can say, right? VOC. So from here only, from our nose and from our smell sense only, they have started developing these electronic noses and other smell sensors, right? It plays a predominant role in diagnosing the diseases nowadays, right? I said, Dr. Herbert Mayo, right? He in 17th century he smelled the urine of patient. He tasted the urine of patient to diagnose the diabetics. right? It happened. And your tongue also, right? From here, nowadays, this is a pandemic situation. We all are isolated from each other, and we all are safe at our home separately, right? We cannot talk with each other in person, and we cannot meet each other nowadays. And the symptoms are loss of taste and smell, right? So taste plays a role here in diagnosing the diseases, right? And tongue has many taste buds, right? And we are using the tongue, and if you don't feel any taste, then there are diseases you can diagnose, right? And it acts as your taste sensor, and last, the touch by finger, right? Your finger, or you can say your skin, the system, the muscular system which is covered by the skin acts as a touch sensor, right? And this touch sensor plays a predominant role here, right? Your pressure, if you want to measure radial artery pulse here in your wrist, then you need to touch your skin, right? By this technology only, they have in our ancestor means our Vaidya or Nadi Pariksha Vidwan, he or she measured the radial artery pulses, and they were able to give the report about the pregnancy also, right? In cinema, in old cinema, we could have seen it, right? Many scenes in our cinema. One old lady will come and she will touch the wrist of girl, and she will say that she will congratulate that you are pregnant, right? So it all happens due to the touch, right? And we have the haptic sensors. Haptic is a separate domain in touch area, right? Touch, the science of touch is called haptic, 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 right? So we have sensors, and we have sensors, and we have sensors, and the modern sensor technology has evolved, right? You see, from the optical sensor, Dr. Herbert Mayo in 17th and 18th century, he diagnosed the diabetics by seeing the urine, the color, the color of the urine, and he smelled the urine, right, of a patient, and he tasted. We cannot imagine how dedicated he was, and how dedicated he was to give the results, diagnose the patient, right? But he did it. He see the urine color, and he smelled the urine, and he tasted the urine even, right? But Herbert Mayo, they were pioneering anatomy and surgery and pathological studies, right? By the time no technology was there, no science was there, and they started developing the sciences and technology from their experiments. Herbert Mayo was one of the pioneers, right? By using the senses. Also there, John Hunter. This is a story. Actually, we cannot imagine that. How could it be, man? He tasted, the semen, right? When he was under research to diagnose the STD diseases of patients in Europe, and he started tasted the semen also. There was a report article in the internet. I have just read it, right? And he was a great surgeon during his time. And James Mackenzie was there, and he used the sound sense, right? The sound sense, right? When he was a intern in an hospital, he got an opportunity to do delivery to the patient. Baby means labor process. He was in. The labor process was good, and that lady delivered a baby, a good healthy baby. And after some time, what happened? That lady died, right? And he was worrying much, and he was surprised how it could have happened, because everything was fine. The process was fine, the labor process and everything was fine. But after a few hours of labor, and the lady died, and he was very much frustrated, and he started self-checking his process, right? And by the time the stethoscopes were coming into the picture, by the time only, right? Before that, the stethoscopes were not there, and doctors started hearing, used to hear the sounds from the by placing their ear on the patient's body, right? Wherever it is required, maybe on chest or the back or their abdomen and everywhere, right? But during the time of James Mackenzie, Dr. James Mackenzie, by the time the stethoscope were coming into the practice slowly, right? And he started thinking about the murmur sounds, right? So there his journey started, and he invented the polygraphs, clinical polygraphs, right? The clinical polygraphs will give much of the physiological information of the patient, right? So he tested the heart sound and taking the physiological parameters, polygraphs results, and he started correlating both the things, right? The sound which he is hearing from the patients and the test results of the patient from the polygraph, and he started testing the things, right? Correlating the things, and he started deciding the fate of the patient, where his journey started, and he was celebrated as a pioneer in the clinical study, right? So there were many doctors who used the senses to diagnose the diseases, right? Not only in European countries and American countries and Western countries, and in India also we had many good doctors who practiced very well in diagnosing the diseases by using their senses, right? So they were very much accurate using the senses, right? So what we have optical in earlier days we didn't have any glucometer setup, right? So now we are seeing that much right? A simple test doctor would have told our father or our grandfather or grandmother or grandparents, whoever else, right? And you go and urinate on the ground and go and see after some time if ants are there, then you are diabetics. Simple test, right? May not be accurate one, but it gives some fundamental results about your diabetics. Okay, and urine test with Benedict solution. This is the slide shows, you know, the Benedict solution urine test, and the urine will be mixed with the Benedict solution, and it will be heated up, right? The mixture will be heated up, and the change of color will indicate the level of diabetics which you have, right? You see 4 colors are here: blue, green, orange, and the brick red color, right? So if your urine and what you say, your urine and Benedict solution mix, which is heated up, will give the blue color result, then you are free of diabetics, right? And thereon your green color gives and the trace of sugar, and orange moderate sugar, and if it is brick red color, then you are at higher risk of diabetics, right? So how they have tested? They have mixed the urine with the reagent and they have heated up and they saw the color, right? So your optical sensor there works very well, right? If it works good, then you can diagnose the things very well, right? This is what they have done. Nowadays we have many devices. We no need to see the colors, the color of the urine and reagent mix, right? So simply you put 2 samples of urine or blood in the strip, then it will give you the result in fraction of second, right? And you will be given the result whether you are diabetics or not, right? Then you go for GTT, glucose taste test, for how long time you have to know for how long time you have diabetics with you and everything. Then that $1,000 advanced test, right? But what was the fundamental? Your optical sensor with you, what you have with you is the fundamental of optical sensors here, right? And the sound sensor, what, see this doctor, this physician, he hears the sound from the baby by placing the baby on his ear here, right? So he hears. Before invention of the stethoscope, doctors used to hear the sound by this method, right? There were many good pictures, maybe funny pictures also, and the doctor who invented the stethoscope, Leonaki, right? And they say in many of the pictures, they say the present day doctors curse the Leonake for inventing the stethoscope, right? And it's a funny, you can go on so that you can get many more pictures about invention of stethoscopes, right? And after that, what he has done, this is Dr. Leonard. See, he has one pipe kind of thing, right? So he increased the distance between the patient and the doctor, right? The reason is that by using this method, by using this method, probably there is a connection between the patient and the doctor, and there may be the chances for the infections, right? So this is the main reason why this doctor invented the stethoscope, right? So his first stethoscope was a tube kind of thing, right? With an opening, with an earpiece and chest piece, right? So this is chest piece and this is earpiece. And this is earpiece. Okay. So this is the thing he has invented. This is the first version of the stethoscope. This is the first version of the stethoscope here. Okay. So he invented it, and he used ear as a sensor, right? And this is the first sensor in the case of stethoscope or auscultation technique. Auscultation technique is nothing but hearing from the research, physiological physics, the human physics, right? This is called auscultation technique. So this is the auscultation sensor. Nowadays we are using piezoelectric sensor and mic and diaphragm sensor and many more things in sensing the sound from our human body, right? But this is the base, right? And we have a nose, right? And the smell sensor, nowadays e-nose are very popular. We have, and the taste sensor, we have talked much about the taste. And we have the touch sensor, how our amma, means mother, diagnosis as for the fever, right? And the earlier days there was no thermometer, and if we feel fever, we would have told our amma that amma, I feel I have fever, and amma will come and she will touch our forehead like this with her fingers, right? Even in the earlier days, doctor immediately after entering his or her room, doctor's room, they will touch our hand like this, right? And they will touch, and they will they would have tried to feel something from our body, right? And they will touch our forehead like this, and they would have diagnosed whether fever is there or not in our body, the temperature has risen up or not. They would have diagnosed it, right? So this is a very important, very fundamental touch sensor. So these are vitals, right? So this gives you the information about body temperature, right? And it gives you the information about your heart rate, you can hear, or heart sounds, right? Heart sounds or heart rate, you can say, means 72 beats per minute, you can count it. Excuse me. Right? These two are important vitals, right? So by using this stethoscope, you can even measure. This is one of the important tools to measure the BP here, right? Blood pressure. Whether if you are using with sphygmomanometer or any NIBP method, non-invasive blood pressure measurement method, anything it may be, the stethoscope is an important tool, and it's a symbol of doctors nowadays, right? Stethoscope, right? Which has a sound sensor in a diaphragm plate is there. Okay, so likewise, so these are all the sensors which humans have, and these are all the fundamentals of sensors technology nowadays what we have, right? So the next part is healthcare industry. What is healthcare industry, right? We can simply say, and in general, we can say healthcare industries are a category of industries, right? We have many categories of industries. Our process industries, refinery industries, your pharma industries, or textile industries, or metal industries. You can say any type of industries, whatever you have in your mind, right? So this is also one of the categories of industries which looks and which has its goal in helping the people to come out of the diseases, right? To diagnose the diseases, right? This is how we can say. So this is called healthcare industry, right? So it has many branches in it. Hospital is a part of healthcare industry, we can say, right? And the manufacturing industries, in the medical instruments manufacturing industries comes under the healthcare industry, right? And service industries, healthcare industries. And nowadays, many industries are developing softwares, algorithms for your Internet of healthcare things, Internet of medical things, IoT, IoT, right? Internet of things, right? Those and all are we are trying to connect in the internet with existing healthcare, and we are getting Internet of things and Internet of healthcare things or Internet of medical things, right? You can say Internet of diagnostic things also, Internet of therapeutic things also, anything you can say. But for everything of this internet, we need a platform where the result is episode and will be retrieved back to diagnose the things, infer the results, infer the data, right? So this is very important thing. And what is healthcare industry? It's a category of industries. Many cluster of industries, many industries are there, and this is one of the industries in our society. And it also play a predominant role in deciding the economy of a nation, right? Not only the India, for other countries, it has a huge impact in deciding the economy of nation, right? And what it does, in fact, it manufactures the diagnostic and therapeutic devices, right? I am not going to talk about the pharmaceutical industries where they are developing the medicines, right? And we are talking about the instruments only. In the instrument part, we have two major classifications, right? Diagnostic and therapeutic. If anything else is there, if you feel I miss it, then you can note it out, right? You can give it in a chat box or later section. You can remind me with other classification also. So to my knowledge, there are two major classification. One is the diagnostic and therapeutic devices, right? So healthcare industries normally manufacture these two devices. So diagnostic devices, what are all diagnostic devices? Anything, it may be right from your stethoscope, from thermometer to your CT and PET and PET images, right? Scanners, right? Anything it may be. And your therapeutic devices, what you can say, your hotline machine, is a kind of therapeutic device, and your dialyzer, your diathermy, your defibrillator, your pacemaker, right? And what else? Your hearing aids, right? Your spectacle can be a therapeutic device because it helps to improve your optical sense, right? Your visual sense, right? So it can be used as a therapeutic device. Your wheelchair, your artificial limbs or therapeutic devices. What else? Anything you can add with this, right? So healthcare industries are working 24/7, 365 days in a year to help the people in the country, in the world, in diagnosing and assisting them, right? By manufacturing the devices, by manufacturing the instruments, right? And on what platform they work on, right? They, of course, they work on the sensors and sensors, right? So without sensors, can you imagine any device, right? Wherever it may be, in your industrial perspective or your healthcare perspective, anywhere it's, right? Anywhere it may be. Everywhere sensor is important. For your IoT, without sensor, you cannot imagine the IoT. Without sensor, you cannot imagine the IoT, right? Once you sense your parameters from wherever it may be, from your industry, your process, or from your physiology, anywhere it may be, right? After that only you can process the data, and you can display the data, you can store the data, you can use it for other diagnostic purposes, and you can give the treatment, you can manage the disease, right? So these sensors and sensors are the fundamental units of healthcare industry upon which these healthcare industries function, right? And of course, hospitals are part of the healthcare industry, right? So this is like a cycle. If you imagine there is no healthcare industry, can the hospitals function, right? Yes, and the answer is yes, it can function, but not efficiently nowadays, right? Because we practice to work the instruments, right? Nowadays, you can say the young doctors, they cannot diagnose the heart diseases fundamentally without the stethoscope, right? They cannot, they will not put their ear on the patient, right? So stethoscope is very much mandatory in hospitals, in clinics, on the table of the doctor, every doctor, right? So, but without hospitals, the healthcare industry can function? Of course not. If they manufacture and there are no customers, and what's the purpose of manufacturing the things, right? So this is a cyclic kind of thing, right? Hospital is part of the healthcare industry, and healthcare industry helps the hospitals and doctors to diagnose the diseases so that they are end users of medical devices, hospitals, right? But nowadays it expands to the homes also. You see, in the pandemic situation, almost every home has pulse oximeter. We can say some 70% of houses in our country, they have pulse oximetry. If I am wrong, maybe 50% we can say, right? If we take the rural population apart, then maybe some 50% of our population or 50% of our houses in our country have the pulse oximetry with us, right? So the end users of medical devices are including the houses also, right? Not only the hospitals. Now it has been expanded to other sector also, right? So everyone is having, in urban background, in urban area, the mothers of kids, they have thermometer with them, digital thermometer with them, right? So it happens everywhere. So health industry, in fact, intrudes to each and every home nowadays very slowly. Thermometer we have at our home, pulse oximeter we have at our home, right? And glucometer we have at our home. We no need to go to hospital or clinical laboratory to test the blood sugar level. Right? So, sometime in some cases, we are testing our blood sugar at our home itself, right? Then we call our doctor and saying that, doctor, my diabetes level today morning is this and so, and what should I do? We are asking, right? Telemetry kind of thing is happening there, right? So the end users are hospitals, of course, the houses also nowadays, right? And the healthcare industry is normal. It's the objective of the healthcare industry is to take care of the human and animal health, right? So here I am mentioning the animal health also. The thing is that normally we don't consider the animal health whenever we are talking about the healthcare industry, but healthcare industry, there are industries which work for the animal health also, animal health diagnosis and therapeutics also. There are vet doctors there, and they rely on the instruments and devices which are being produced by healthcare industry exclusively for the animals, right? But we can say human health is foremost priority, as foremost priority. Of course, healthcare industry cares the human and animal health, right? This is also one of the definitions we can say about healthcare industry. And what is the scenario, Indian scenario? You see, in Indian scenario, it's a report I have taken from internet only, right? By 2020, it was a 200 billion US dollar economy for healthcare industry in Indian scenario, and it's expected to be around 375 billion US dollar by 2022. Right? You imagine how much revenue it's being generated by using the healthcare industries in the country, right? But still, we are not able to develop our indigenous devices, right? The first session, Mr. Krishnan, he talked about the devices, right? And I don't think many of the healthcare industries available in our country make the indigenous devices or instruments in our country, right? Still, we are hiring the technology from outside. Still, we are assembling the components at our homeland, and we are making it as a device, right? There are very few instruments indigenously developed in our country, right? So even though the economy, the revenue being generated by healthcare industry in India is Presently, it's about 200 US billion dollars, right? It's expected to be another $100 billion in 2022. $375 billion is expected. So you just imagine the impact of healthcare industry here, right? So healthcare industry works on, again, sensors and sensors. So it's very important. Okay. And what happened next? So they have developed, right, many things. And in the previous slide, we have seen, right, the Benedict solution, urine test, diabetics, and everything, right? And this is another part of sensor. They use the light, right, light rays, and the lens, and the slides. Right. This is very fundamental instrument, very basic instrument in all clinical laboratories. We could have seen very earlier, right? Nowadays, the clinical analyzers have come up. The blood analysis, automated, semi-automated analysis have come up, right? We no need to take the blood sample and put it in a glass plate and add the reagent and mix it and place it on the microscope here in this place, right? And put on the light and the rays will be going here, right? And you adjust the lens here, these three lenses, and view from it, right? Then you will be seeing some small atoms, some small worms, small creatures, bacteria, viruses, which are moving in that sample mixture, right? This is what happening there. In earlier days, but nowadays it's not there, right? So what it replicates, in fact, you are seeing, and other than seeing with your bare eye, you are using a tool here. This tool has been developed by the healthcare industry, right? By using the optical sensor, we have the light here, right, and the lenses here, right? We have our retina. It's basically a lens, right? And they use this technology to develop this microscope, right? Magnify the things, right? With a bare eye, we cannot suppose some very microorganisms, right, in the fluids of our body. But they started using these microscopes to see the microorganisms in body fluid. That's what happened. The microscope was invented, right? But nowadays we are not using. I think we are not using this type of microscopes, but we are using the digital microscopes, right? So what was happening earlier in these slides? You need to see through this eyepiece, and you will be seeing these microorganisms, right? Where? In your eyes. But here, these microorganisms, whatever you are placing here, will be displayed over the display here, your LCD display, right? The optical sensors works here. So you no need to see through this thing, right? And you can see the microorganisms present in your body fluid in this display. So this display will give you information about all the microorganisms, your bacteria, your virus, what else, everything you can see there, right? And you can even store it, but here that's not a possibility, right? You cannot store anything here, but you can even store here, and you can use it for other research purposes. You can retrieve it back to trace the history of the patient, right? This is happened there. This is a kind of optical sensor here, right? And in the case of stethoscope, what happened? Initially, the physicians put their ear on patient, right? Then he developed a long pipe to hear the sound, right, with chest piece and earpiece, right? Then he invented the stethoscope, right? Now this has become this stethoscope has been invented by scientist called Lippmann. He is a physician. He was a physician, European physician, and he invented this stethoscope. He is one of these modern stethoscopes nowadays. What all the doctors are having in their hand, right? So this is stethoscope, and this has become a symbol of doctor, symbol of medical professionals. Okay, and after that, what happened? Again, digitization came into the picture. Nowadays, we are having the digital stethoscopes, right? By using, we can magnify the sound, magnify the heart sounds. We can clearly hear the murmurs, right? So, what sensor is being used there? Here, we use only the diaphragm, the thing which is inside this dome is called diaphragm, right? We use the diaphragm as a sensor here. Right? And they started digitizing the things. They started giving the digital thermometers, right? So of course, if we want to digitize something, of course the electrical signal would have come out. It should come out, right? And to get the electrical signal, we need to have the transducer, because transducer principle, we know non-electrical parameter to electrical parameter, physical parameter to electrical parameter of any kind, your resistance or voltage or your frequency, right? Your capacitance, inductance, in any parameter you can get, and you can process it, and you can get it for your convenience, right? In readable format you can get it, right? So what happened here? They started using the diaphragm again, or the piezoelectric crystals, right? Or any other crystals which will react, which will to your mechanical vibrations, right? And it will convert it to audio signal, and it will be stored there, right? If you don't want to hear it as a signal, audio signal, you can make it. If you want to make it as a graphical representation, then you can make it here. The stethoscopes here, right? So thus the digital stethoscopes have come into the picture, right? And these are very few digital stethoscopes. See, here you can modify the things here, right? You can improve your amplification factors and everything, right? And you can connect the stethoscope. This is the chest piece, right? You just need to put this chest piece on the chest of the patient or back of your patient, right? And it will be heard in your mobile phone here. It can be connected with your mobile phone, right? And these are other versions of digital stethoscope. Plenty are available in market, right? But anyhow, this is the fundamental nowadays. The doctors have been using this stethoscope as a fundamental diagnostic tool to measure one of the vitals. Right? There are 4 vital parameters in our body, right? Your heart rate, your blood pressure, your body temperature, and your what is the 4th one? Sorry, I don't remember the 4th one. Probably before the end of this session, I will tell you the 4th one, right? And they have added the painless also, fifth vital sign, right? So out of 5, we have now 4. Let us discuss what is the 4th one, right? So this is about stethoscope and recording your smell sense. Nowadays they have the e-noses, right? And this is one kind of e-nose. Right? The patient, she is being asked to exhale, right? Breathe out the air from her, and this is a sensor arrangement here, right? And it will have electronic spot inside, right? So this will sense the compounds which are present in the exhale patient, right? And it will sense the volatile organic compounds, VOCs, right? VOCs, volatile organic compounds present in the patient's exhale, and it will give some results, right? What is the percentage of the compound present in it, right? So this amount, this quantum or this quantity of this volatile compound relates with the disease, any of the disease. And these type of equipments are very popular in diagnosing nowadays the malignancies, cancer, right? And of course there are many other diagnostic procedures also there, and the pathological procedures, and you can take the sample, give it to the lab, and they will do analysis, and they will check whether what is the condition of there in the particular area, and they will say whether it's benign or malignant, right? And this is very important. And the bottom figure, this shows again they use the smell, right? But here they use the honeybees here. You see, these 3 are honeybees, right? From which we are getting honey, right? So they use the honeybees as a sensor, and the patient will be asked to blow out the gas, and it has 2 sections. One is the outer section here, right? And another one is the inner section. 2-part container, right? And this is the first part, and this is the second part. In the second part, the patient is asked to blow out the gas, and these honeybees will be there actually trained, right? We can say we have given intelligence to sense the particular right. Nowadays for COVID patients, the sniffer dogs are being used to diagnose the COVID patients, right? So it's under practice. They are doing research in it, right? But they have done already with honeybees there, and if the relevant if there are changes in the components, right? That's all for everything, right? For your heart rate, it's for the heart rate, it's 72 beats per minute, and for your blood pressure, systolic 120 mmHg and diastolic 80 mmHg. There are ranges, there are thresholds. If there are some changes in this threshold, then we can say he is infected or he is affected and he is ill, right? Likewise, in volatile compounds also, the mixtures or the mixture of gases are in a particular level. If there are changes in that level, then these bees will tell you the information, right? It will not give you the quantitative information, right? For your information, it will not give quantitative information, right? But it will approach this piece, means this opening, right? If it approaches there, then they will be correlating with the disease, right? Right. So this is all about here no electronic part involved, right? But here the electronics is involved. Okay. So this is how we are using the sense of smell, right? And last, another vital, we have the body temperature, right? So in the previous slide, we have seen one mother touched her baby's forehead like this, and she tried to come to the conclusion that whether his baby is in fever or not, their baby is in fever or not, right? So this is very fundamental sensing method. And after that, what they have done, they have developed the mercury thermometer, clinical thermometer, and this is a mercury thermometer. Nowadays, we are not using the mercury thermometer because we are not skilled enough to read this thermometer at our homes, right? So for our convenience and for our comfortness, the technocrats or the engineers started developing the digital thermometers, right? With the sensor, right? Maybe with a sensor probe, a long probe inside the digital thermometer, or a bead, right? Bead of RTD or basically they use the RTD or thermocouple, right? So thermocouple or thermistor they use there, and this is a bead, and this will be the tip. In this tip, maybe the probe or a sensor bead here, and it will be touched with your human body, like your part, maybe your skin, your armpit or your oral or your anus, everywhere. For infants, they normally test with the anus. Okay, so this is happening there, and they started giving with the digital thermometer, and later on stages some strip kind of things also they have started giving, right, with LCD liquid crystal sensors, right? Your what is it, organic LED, OLEDs sensors are also there, display devices are there, and we use liquid crystal thermofluid liquid crystals. They started using it, right? So this is simply a strip. You can place a strip over your forehead, and based on your temperature, body temperature, it will change the color and it will indicate your temperature level also, how much it is. Probably your 98.4 or 100.3 it will give, and the color will also get changed, right? It's simply a strip. You no need to carry this mercury thermometer or digital thermometer of larger size, right? And there were non-contact type of the temperature transducer also, temperature sensors also, thermometers also are also available nowadays, right? They use the temporal artery temperature, and they use the IR sensor there, right? So infrared light is emitted from the instrument, and it touches your temporal artery here in the forehead, right? And here, based on the temperature in your temporal artery, the reflective light will have some changes in its frequency and amplitude, right? So it will be calibrated to your temperature, right? This is how your what to call your non-contact type of temperature sensors are working, right? Thermometers are working, right? So these are all very few. This is your digital thermometer normal. Probably many of us have this thermometer at our home, right? But this may be very new, and in Western countries and American countries, they use it, and in corporate hospitals in our country also, they started using this type of strips, especially for kids, infants, right? So they will not be allowing us to put the thermometer in their armpit or their anus somewhere else, right? So it is very easy. You can place the temperature strip there. It's very easy, and this is very common nowadays. Wherever we go, in the railway station, airport, bus station, or malls, hotels, everywhere, the security is standing with this type of thermometer, and he is asking us to show our forehead, and he will check our temperature, right, for this pandemic situation, right? And this is happening there, right? So these and all are very important part, and this is how the healthcare industry works on, and sensors they have been using, right? And there are very few other sensors also. I can say this is optical sensor, the oximetry now we are using. The principle behind this oximetry. This is called oximetry, right? Oximetry, where we are measuring the SpO2 level and our heart rate, right? Heart rate we are measuring, right? So what is the principle behind it? We are using the light emitting diodes here, means probably red light, and the phototransistor or the photodiode, or in common you can say photo detector, any type of photo detector, right? So the blood is flowing inside here, right, inside the finger, and the light is passing through the artery here, means blood vessels. So depending upon the composition in the blood, it will give the SpO2 level, right? So what they have done in this oximetry, this type of sensors are there, but nowadays they have started using the strip sensors, right, with advancements in material science. They have started giving many good micro sensors and nano sensors, really thanks to MEMS and nanotechnology nowadays. We have to thank that, right? They have reduced the size of everything, right? And we can say very funny that they are not trying to miniaturize the human being so far, but we cannot sure that one day or another they will miniaturize a human being also by collaborating with a biotechnologist, right? So it will happen one day, who knows, right? And after this, they have started using this type of OPDs, right? Optical photo detectors, many very small chip level photo detectors, and here they are using OLED, right? And this is a red OLED and green OLED, and this is called the organic photo detector. See the size and the shape of the sensor. It's like a ring, right? Maybe it's not, we cannot say this is a metal ring kind of thing. It's a paper ring. You can easily wrap it around your finger, and the information will be sent to your mobile phone or your doctor consult, right? What is the SpO2 level and what is your heart rate, and everything will be given there. You no need to carry your pulse oximeter here with a battery and other thing. You no need to carry everything because it's a bulky one, right? It's a very miniaturized one. Much of miniaturization happens here, right? Thanks again to MEMS and nanotechnology, right? Fabrication technology, right? So this is about your heart rate and SpO2, right? This is one of the advancements we can see nowadays in the market, even at our homes, right? But of course, we are not using this type of technologies at our home at present, but very soon we will be using. But we are using this pulse oximetry at our home, right, for diagnosing the SpO2 level and heart rate, right? And the next one is your sphygmomanometer to measure the BP. This is again one of the vitals, right? So it has a mercury manometer, and it has the cuff, right? And it has a bulb here, pressure bulb. You can pump it out. You need to wrap it around your brachial artery, brachial arm, and you need to pump it and you need to reduce it using the stethoscope. You should hear the Korotkov sound and everything, right? So you see, when you have watched the old movies, if you have doctor in that movie, the doctor's suitcase, briefcase must have two items very importantly. One is stethoscope and another one is sphygmomanometer. Whenever he enter into the hero's home or heroine's home to check them, and he will open the suitcase and take out the sphygmomanometer and put it and stethoscope on chest or back and everywhere he will check. Right. So this is again a symbol of medical professionals, right? It's called sphygmomanometer. But now these instruments have been automated. Right? You no need to pump the pressure bulb again and again to increase the cuff pressure over your brachial arm, right? It will automatically does. It will automatically do. It will automatically increase the pressure in the cuff there, right? Like your automated BP apparatus, right? So this is one of the BP apparatus. You know, you connect this cuff with the instrument here, right? And wrap your cuff around your brachial arm, switch it on, it will automatically give you your systolic and diastolic value. See, systolic and diastolic value. It will give. It's automated. You no need to pressure. You no need to give pressure using your pressure bulb, right? So what's the sensor is used there? At last we need the output, right? And what is the principle behind it? We need to hear the Korotkov sound, right? So if it is an oscillometric method, then you need to hear the Korotkov sound. Means you need to have a sound sensor here, right? So whenever the sound signal is received in the sound sensor, maybe your piezoelectric crystal or your diaphragm, anything it may be, right? Then that is the systolic pressure, right? 120. When this sound sensor stop listening, stop receiving the Korotkov sound, then that is your diastolic pressure, right? It will be given to your electronic part, your filter, your amplification, and your processing part, and it will be interfaced with your display. It will be displayed over there, right? So everything is automated. So here, what's the sensor? Important sensor we are using? Our sound sensor. Sound sensor of any size. You can go to the limit. Sky is the limit. You can go to any limit, right? In the case of size, right, and accuracy also, right? So nowadays, material sciences give a lot of information, lot of outcomes to the technocrats and engineers, right, to develop many instruments, many devices, many sensors, right? So these and all are part of your blood pressure measurement kind of thing, and see how miniaturized sensors they have given to us, right? And this like sensor only I have used for my research also. I have developed one small device using this type of sensors, piezoelectric sensors, right, to measure the radial artery pulses, which I will show you soon in this presentation. Okay, and this is for measuring the pressure, and for your temperature. This is what I have shown you, that I have told you now, that STIP temperature sensor. So this has all these parts. Your polyester film is there, white graphic print, black graphic print, and this is important, liquid crystallines, right? So it changes its color based on the temperature of the medium, right? So this is very important. This is a sensor here, liquid crystallines, right? And other parts, 1, 2, 3, 4, 5 other parts, other 5 parts are part of your fabrication process, right? So you cannot use this sensor alone to measure the temperature. You know, it should be in an instrument form, instrument shape or device shape, or your STIP shape, something else, right? So for that they have used all these things, but this is very important, this liquid crystal temperature sensor, right? Again, thanks to the material science. Right, and they have started using this type of sensors also. Your temperature sensor, DC, this is the temperature sensor, right? I am not much expert in talking about the material side, right? But I can wonder, oh, how beautifully they have made all these things and everything, and I can use it, right? But if you have interest on material science, and if you have interest in fabricating the sensors, making the sensors, and there are much of research scope, much of entrepreneurial scope in this area also. You can explore these things, right? Very significantly, and it's a very interesting area of research also, very interesting area of making the money also in monetary point of view. Okay, so I have concluded this with the temperature, and of course I have used temperature as one of the part in my research also, in my pain research also. So I have done pain research, and I know you all. I hope you all know what is pain, right? Pain is something you feel, right? But what we think about the pain is that pain is a disease. That's what we are thinking. But actually, pain is not a disease. It's not a disorder. It's a symptom. It's an indicator of the health condition, right? Individual's health condition. So that's how we need to approach the pain. But how we are approaching the pain is something different. Like we are approaching the pain, we are managing the pain as a disease, right? Because whenever we feel the pain, we approach a doctor. Suppose if we have headache and severe headache for 1 or 2 days, and we are visiting the doctor, and doctor will ask us, how do you feel the pain? Whether it's a pricking pain or the pressing pain, right? Or the throbbing pain or the burning pain. What kind of pain you feel? Then we will say that no, it's a pressing pain. I cannot tolerate the pain. So he will ask what is the level of your pain? And we can say it's a huge pain. I cannot tolerate. I cannot even shake my head like this. And anything we can say, right? So based on our answers to his questions, he will prescribe the medicine, and of course the dosage of the medicine also, the painkillers also, right? So to kill the pain, we need the killer that is called painkiller, right? There are many NSAIDs, many steroids, many painkillers, many diclofenac sodium, aceclofenac sodium, many NSAIDs we have, and these paracetamol, right? And we have been asked to administer these drugs based on the report what we have given to the doctor, right? He is asking question and we are answering, and we can answer anything. If we want to get rid of the pain very quickly, and we will be saying the doctor that doctor, it's intolerable, we can say, right? And based on which he will write. And he is not, he or she, the doctor is not measuring the pain there. He or she is measuring the pain very subjectively, right? What is subjective? It's all depends upon the subject, right? Who is subject here? We are the subject. The patients are subject, right? The subject will be asked some question, and subject will be entertained to give some answers to the question. Based on the answers, the management procedure will be decided. The therapeutical procedure will be decided, especially in the pain case, right? So in the pain measurement, we have two classifications. One is subjective pain measurement, and another one is objective pain measurement. Right. In my research, I was trying to make, and I have been trying to give a pain meter based on the objectivity of the pain, right? But as like in other new emerging areas, whenever it comes into the society, there will be a huge reluctance, there will be huge resistance will be there. I am also facing the same. This area is called as utopia. Utopia? It will be there in imagination. It cannot be existing, right? That's what I am getting responses from the senior researchers and senior biomedical engineers from our society, from our fraternity, right? But still I am trying, and I have tried with a few experiments. Let me introduce my research, and let me take this opportunity to present my research area also, which will be related to some extent with this topic, sensor in healthcare industry, because I also want to give something to the healthcare industry from my side as a biomedical engineer and as an instrumentation engineer. Okay, so this is about pain. Pain is being defined as an unpleasant sensory and emotional experience associated with actual or potential tissue damage, right? So what creates a pain? Your damage in your physique will only create the pain. If there are no damages and there are no dysfunctions, then you will not feel pain, right? So this damage or dysfunction may be on physiological side or your psychological side, right? This is how it happens, right? So whenever you have something bad in your health, right? Suppose if you have some cut in your finger or your hand or some wound there in your body, then you will start feeling the pain, and the pain will indicate you there is a cut in your finger. Suppose you imagine if you don't feel pain after you have cut here, what you will do? You will do nothing, right? But cut will be there will be bleeding, and you will be under blood loss, right? And you will be fainted, and in many cases it will lead to the death also, right? So pain happens due to some damages in your tissue, right? This damage may be this damage may be your physiological damage or mental damage, anything it may be. So this is what they have classified the pain also: neuropathic pain, right? And the somatosensory pain or the visceral pain. Especially this neuropathic pain is related with your mental illness, right? This also happens. So it's defined as an unpleasant sensory and emotional experience associated with actual or potential tissue damage or described in terms of such damage, right? This is defined by IASP, called International Association for Study of Pain. They are premier in doing pain research nowadays, right? And it is pain is a symptom or infirmary, we can say, and it transmits information from the location of tissue damage to the cortex of the brain, where it is processed, right? Wherever may be your damage, and it will be processed there in your brain, and it will indicate you through the pain, right, for further actions and further responses. This is what I described here in this picture. See, this is the area of your tissue damage. This may be in your body anywhere, right? And area of tissue damage is here. From here, the pain signal is transmitted. I'm not going to discuss much about the pain signal because they are neurotransmitter, acetylcholine and kind of thing. It's basically a electrochemical reaction, right? So this pain signal will be transmitted to the cortex of brain through the specialized nervous system, efferent and afferent nervous system, through your spinal cord, right? To the cortex of the brain, where it is processed. And what happens in this process? It will check what is the level of damage, right? And how much the damage is there, and to which motor neuron we have to trigger out. This is what happens here, and the motor neuron will be triggered out here. That is called a response, right? So due to this response, we will be reflected back and we will be acting back, right? This is called reaction or physiological system. We will be saying, right? Suppose there is a mosquito bite, and this due to this bite there will be a damage, and this damage will be processed, given to the brain, and it will be processed here, and it will ask this limb to go there and say or hit, right? And due to this bite, the fundamental of my research is that there is reflection in physiological system. This is very important, right? So whenever you have some damages, whenever you have some changes in your physiological systems, then it will be reflected in your physiological parameters, whatever you are measuring out. Maybe in your heart rate, your blood pressure, your ECG, your EEG, EMG, or your resistance of your skin, right? Anywhere it will be reflected. Of course, it will be reflected in your brain. If you image your brain cortex, then you can visualize the changes happening due to the damage happens in your body, in your cortex, right? There are fMRI studies available in research, right? And they are still doing it in UK. fMRI pain analysis, right? And we are also trying to do that, but it's a very costly procedure, you know. So we need some fund, and we are trying to get fund from agencies, right? So this is a basic of the pain research, and the basic of objective pain measurement is this Tirukural only. And for the friends, those who have joined from other parts of the country, we have a poet called Thiruvalluvar, named Thiruvalluvar, some 2000 years back, right? And he wrote some 1330 poems, two-line poems like this, right? For us, he teaches the life of every human being. He actually gives information about how to live in the society, right? So this is one such Tirukural. I can say this is the fundamental Tirukural for my research. Noi nadi, noi mudal nadi, adadanikum, vai nadi, vaipachayil. Might be the Tamil participants, those who have joined here, might have known this Tirukural very much, right? Noi nadi, noi mudal nadi, adadanikum, vai nadi, vaipachayil. So we have to identify first the cause of the disease, right? We have to, then only if we know the cause of the disease, then you can decide the treatment procedure, how it could be treated, right? Unless you know the cause of the disease, you cannot treat the disease, right? If you consider pain as a disease, and it's very wrong, it's a symptom. So what is the cause of this symptom? Where from it emerges, this symptom emerges, there you have to treat, right? So this is the fundamental thing. So this can be diagnosed only by analyzing the parameters. That's what, as an engineer, I am saying, right? And other pain researchers also. Very few pain research, objective pain researchers are there in world countries, and they are also believing the same, right? But we cannot substantiate these things with the doctors, right? That's what we are trying nowadays, right? So this is the Tirukural based on which my research lie on. And we have two types of pain measurement. As I told you, subjective method and objective method. Subjective method, self-report and observational or behavioral methods. And those are not much of reliability. And we cannot rely the results based on the subjective measurement methods, because it's based on the conversation between the doctor and the patient. But we have to believe always the data, right? And if you get some data from your patient, then it will talk and it will give you information about your patient's health condition, right? That is called objective methods. So objective methods fall on the measurement of physiological parameters when you feel the pain, right? And you can analyze the parameters, right? This is what we are trying. And I have developed two types of pain inducers. One is mechanical pain inducer, right? And in another part, I have developed a thermal pain inducer also, right? So by using the mechanical energy, we can develop the pain. Some questions might have been raised, like why do you need to induce the pain, right? We cannot check with the patients, real patients, and the attendants or the patient himself will not allow us to do experiment on them, right? Even we are not also not allowing anyone to test on us, right? It's a huge procedure, so I can induce the pain, and I developed a mechanical pain inducer, which has it looks like this only. It resembles the Tower of Hanoi, right? And it has a fixed iron disc, and a metal tube is here, and these are 1, 2, 3, 4, 5, 6, right? These are metal plates of weight some 0.5 kilo, 500 grams, and it can be inserted here. So here is a hole, right? And by through this hole, you can insert these weights in this rod here. You can write. So if you increase the number of discs over and over, and the load act on this metal cube, right? It's a 1 centimeter cross 1 centimeter metal cube, and the load will be increased at this point, and this metal cube is placed in this part, right? Any part you can see. So to get the better pain reflection, we have put this metal cube and put the belt over it in this part, because this is a very small area, in this small area a huge load will be acted, so you will get pain feeling very soon, right? So this is one of the mechanical pain inducer we have developed, and it's a portable manual operation, simple structure, we can see, right? And we have developed thermal pain inducer also. It's a nichrome based. Here I want to say, this is the part which we have made in our laboratory. to making this setup, means especially this setup, we have spent a lot of time because we consider this is a separate device, right? So it has a copper plate in it. It's like a box, right? It's like a box, right? So on the bottom of the box is covered with a copper plate, and inside which a nichrome coil is placed. So this nichrome coil will act as a heater, right? So we have to radiate this heat, which is being emitted by the nichrome coil, has to be radiated to the patient's or subject's skin, right? Wherever it may be, in any part of your body, you can place, right? So for that, we have placed the copper plate here due to its thermal efficiency, right? We have chosen copper because its thermal resistance is very low, means it can radiate, it can radiate the thermal energy very easily, right? So we use the copper plate here at the bottom, and inside this box we have nichrome coil, and all other parts are closed. 1, 2, 3, 4, 5. 5 parts are closed with a thermal insulator, right? And the bottom part has been made with a copper plate, right? And this device will may be placed on the human skin over it, right? And if you increase the current which is applied to the nichrome coil, then the more heat energy will be generated, and we can control it by using the temperature controller here, right? So this is the device we have developed to induce the pain, thermal pain on the patient, right? And again, here we are using the touch sensor, right? So unless you touch your skin with this device, and you will not feel the pain, right? And the temperature can be measured over here, right? So this is one of the pain inducers we have developed, and the second pain inducer also we have developed based on the Peltier effect, right? So why we have gone for Peltier device? We can create pain by using the cold heat also, means cold what to say, cold temperature, right? Cold temperature, right? In sub-zero also we can develop, right? So if we keep some ice cubes in our hand for some 5 to 10 minutes, then we will start feeling the pain, right? This is called thermal pain, right? So Peltier device will help us to give the temperature on both the end, right? On cold side and hot side, both end we can get, right? So this is the thermal pain inducer we have developed, and I have told you now, one pressure sensing device we have developed using the pressure sensor. This pressure sensor is basically the piezoelectric sensor, right? And we have used this pressure measurement device to measure the arterial pressure, especially the arterial pressure, right? Arterial pressure, Vata nadi we have. We have 3 nadis in our human body, right? One is Vata nadi, and another one is, those are Vata, Pitta, and Kapha, right? Vata nadi is closely related with your pain. The Siddha literature and Ayurvedic literature say, right? So we try to measure the Vata nadi in this radial artery. So this is called radial arterial pressure. And this radial artery, to measure this Vata nadi in this radial artery, we can develop this device, right? It's a sensor, it's a piezoelectric sensor, and this piezoelectric sensor we cannot develop. We have used this piezoelectric sensor to develop a device to measure the radial artery pressure. Okay, and we measure the blood pressure also. To measure the blood pressure, we use the simple sphygmomanometer kind of thing, right? And it will be is the electronic sphygmomanometer. So this electronic sphygmomanometer will be connected with your NI LabVIEW software, and we have got these results, right? And by using, we have done 3 types of experiments with 2 types of inducers. With mechanical pain inducer, we have measured the dermal and cardiac parameters. Dermal parameter means we have measured the GSR, right? And dermal parameters, we have measured heart rate and blood pressure. and with the thermal pain, we have measured the temperature and heart rate. Right. So I'm saying we have developed two pain inducers. One is mechanical pain inducer and another thermal pain inducers, and we have measured different parameters of physiology. One is dermal parameters and another one is cardiac parameters, and body temperature we have measured. With the thermal parameter we have measured the heart rate also. With the mechanical pressure we have measured the vata nadi. Right. So I wanted to prove there is a relationship between the vata nadi and the pain. Right. Definitely there is there, but we have no any scientific proof over it, because in our tradition we were not practiced to document anything. Right. But we have to document everything in the scientific manner. Right. So I wanted to do that, and I have measured the vata nadi. There was a good result I have got, and the other cardiac parameters like your blood pressure. Right. So this is the experiment I have done, and I have done this experiment in 3 different stages, right? And for pain, pre-pain, pain, and post-pain. Pre-pain mean without applying any pain, and during pain mean applying either mechanical pain or the thermal pain. And after that, the experiment will be stopped, and after 5 minutes gap, 2 minutes gap, again the same parameters will be measured, whether your GSR or your heart rate or your blood pressure or vata nadi, anything it may be. It will be measured there, and the results of these 3 stages will be compared, right? Whether there are changes due to the application of pain, and there was changes in all these parameters. But in GSR, in galvanic skin response, the GSR, the changes in GSR shows very good responses for the pain, right? Other than these things like your other cardiac parameters, right? So GSR shows a very promising results there, and we are working on other parameters also. We are working on imaging techniques also. We are trying to working on it, and we are waiting for the fund, and we are waiting for the scholars to work on this area. So I wish to develop a pain meter based on the objective pain measurement method, and I wish to develop the pain inducer, automated pain inducer of mechanical, thermal, chemical, any kind of thing. Chemical pain also we can induce for research purpose, and this part is for research purpose, right? The developing the pain inducer is for research purpose, and the pain meter is for the societal purpose. If we develop a good pain meter and good pain measuring instrument, and it will be there on every doctor's table, and it will largely reduce the amount of painkiller, right? And of course, in turn, it will reduce the side effects of the painkiller. Now we are talking about the side effects, right? Steroids and black fungus, white fungus, and if you give steroids for COVID treatment, and it will affect therein other way of affecting with the black fungus kind of thing, right? And we are still there are debates about the vaccines, right? What are the side effects and all? So if we measure anything very clearly, and we can control it very clearly, very efficiently, very accurately. That's why I am stressing to develop the pain meter, right? So it should be very much accurate, and it should be affordable, right? So I invite all my fellow researchers and all my scholars to take part in this research and do this research. I welcome you all. If you are interested for collaboration, if you are interested to do this research, and you are always welcome, and you can contact me at any time, and you can discuss with me anytime regarding this research. Not only this, and other researches also. I am working on other automations also. I am working on biomedical waste management, especially the sanitary napkins and the condoms, used condoms, right? There are no good work on the incinerators for sanitary napkins and incinerator for condom. And even we can say there are something for sanitary napkin disposal, but there is nothing for condom disposal, right? So we are working on that area also, biomedical waste management, especially these 2 parts, and other biomedical waste also, right? So I invite you all, and I welcome you all to do pain research. One or other day, let's hope to give the pain meter to the clinical fraternity, and let the society enjoy without painkiller their life, right? So let's check the origin of the disease, and we will treat the disease accordingly. Thank you so much. Karupasamy sir, I am done. If there are any discussions further, then we can go for it. Otherwise, may I quit?
Okay, sir. Session is there. Shankar sir,
Yes, sir.
continue the session, sir.
Yeah, it's over from my side.
Over. Okay, participants have any clarifications, any queries?
There is a one question. If the chemical pain induces become a reality, could we use it to bear the labor pain? Actually, inducer will not reduce the pain, ma'am. Inducer will induce the pain, in fact. We are using the pain inducers to check the objectivity of the pain for experimental purpose. If it goes well and it gives us good result or the expected result, then we need to validate with the clinical trials, right? And there are different types of pain. In fact, labor pain is one of the important pain. It's unbearable pain, right? Even no human being from the male side, nobody can tolerate this. This is what the literature says, and every female says, right? And pain inducers will not be useful to clear the labor. It's called pain inducers are for experimental purpose and research purposes.
Shankar sir,
Yes.
sir, from participants, Arul Teresa asked one question, sir. If the chemical pain induces became a reality, would we use it to bear the labor pain? She is asking, sir.
Yeah. I have seen that question and I have answered it just before.
Okay, sir.
Yeah. And
The participants, any queries?
yeah, Mr. Kannapirana has asked one question: how accurately we can measure severity of pain? Yes, that's what I have told you. Like if we measure the parameters, changes in parameters with a pain input, then we can measure accurately the severity of pain also. So if the pain intensity is more, then there will be more changes in physiological parameters what we intend to measure, right, sir? So that's what I'm coming to say. So we need to do a lot of experiments with a lot of subjects with different types of physiological parameters. Then we can easily measure the severity of the pain also. You make note of one terminology called threshold of pain, right? It's a very important thing. You go and search what is threshold of pain threshold. And I think Karupasamy sir, am I audible?
Yes, sir. Yes, sir.
Karupasamy sir, can you share you can share my contact number and email ID with the participants, na? Or should I share?
Okay, sir. Definitely, sir. Sir,
no, we will share, na? I no need to share, right?
Okay, sir.
Yeah, because one of the participants has asked me for my email ID and phone number. You can share with the participants, right?
Okay, sir. Sir,
Other participants, you can visit my page in NIT Silchar web page, and you can get information over there also. NIT Silchar web page, Electronics and Instrumentation Engineering Department.
And Loudraj, please unmute your mic and ask your question, sir. Loudraj.
It's Lourdraj, I guess.
Lourdraj. Hello.
Lourdraj, are you there?
I'm audible. I'm audible.
Yes, sir, audible.
Yes, it's a very informative session, sir. Thank you for sharing this wonderful information. And I
Thank you,
have
sir.
a question, sir.
Yes, sir.
Regarding the reading the sensor can read that information, if there is any gap between the first and second reading while it is read, is any calibration that we follow?
Yes, sir. We have studied about the dynamic and static characteristics of the instruments and sensor, sir. Definitely the calibration is needed there. It depends upon which type of sensor we are using, right? So there are different standards for different type of sensors by using which we can calibrate it before going for the actual user. And it's very much important for medical practices, sir. For all the medical devices, there are very stringent values. This point of time, we have to calibrate the instruments and so that we can avoid this type of errors which you mentioned here. It's very much important, sir. I think Ludra, sir, I have answered your question. Is it convincing or I have to talk something more? And there is a question from PSR 105. What is the effect of aging of electrical components in sensing? Of course, it will be sir or madam. So that's why we need to go for calibration to calculate the error accuracy.
Next, Dr. Shankar, ask your question, sir.
Sorry,
Sir.
I don't hear you, sir.
Siddha Shankar. Dr. Siddha Shankar, are you there? Please ask your question. Participants, do you have any queries? Dr. Siddha Shankar, are you there? Please unmute your mic and ask your question. Any queries from participant side? Okay, thank you.
And
Next, we start
participant
both of them.
PSR 105. My answer is convincing, or we need to discuss something more, sir.
Sir? Shall we conclude the session, sir?
Sorry, your voice is breaking, sir. Karpasamy, sir. At my end, maybe due to the internet issue at my end, I do not know.
No, sir. Your voice is clear. On our side, I think there is no disturbance. Shall we conclude the session, sir? Shankar, sir? Shankar, sir, are you hear my voice?
No, your voice is breaking, ma'am. I am not getting your voice very clearly, continuously.
Okay, sir. Shall we conclude, sir?
Should I unmute my? Should I mute my mic?
Mute.
Yeah, I'll try to mute my.
Shall we conclude the session, sir? Okay. On behalf of our management, we thank our resource person, Dr. Shankar Krishnan, sir, Assistant Professor, National Institute of Technology, Silchar, who despite his busy schedule has found time to honor this occasion. He shared his knowledge and research ideas in the field of fundamental sensor technology and also sensors used in healthcare industry. We thank for his valuable contribution in the field of manufacturing device for diagnostics and therapy devices. Thank you, sir. Thank you for all participants. Dear participants, we will start the next session at 2:30 p.m. The session topic is industrial automation using sensors. So all the participants are requested to join the session at 2:25 p.m. Thank you. Thank you, Shankar sir. All the participants are requested to fill the attendance as well as feedback form.
Karpasamy sir, may I leave?
Okay, Shankar sir. Thank you so much. Very informative session. Thank you.
Okay, I understand. Actually, your voice is breaking, and I understand you are giving me permission to leave, and I will call you over phone. Thank you, sir.
Yeah, okay, I will make a call to you.
Yeah, thank you so much. Thank you so
Okay,
much.
thank you, sir. Thank you for your session.
Yeah, convey my regards to Valarmati ma'am.
Yes, thank you.
I'll call you
Yes,
over
I will.
phone. I'll call you over phone.
Okay.
Okay, thank you, sir.